Hi, this is Dr. Thomas, math instructor at Lawson State Community College, and in the presentation I will talk about inverse functions. The inverse of a one-to-one function is obtained by switching the role of x and y. So for example, if you look at this graph right here, you see that in red you have a graph, and look at one of these points here. You have the point 0,2 here, and this blue represents the inverse of that function in red. That blue, notice that that point that is touching where it crosses the x-axis, that's 2, 0. So notice that they switched the x and y role of the coordinate or the ordered pair to obtain the inverse. So the point 2, 0 is the inverse of the point 0,2, and likewise they did all the other points like that, and they came up with the inverse function in blue. Now this green line here represents the line y equals x. So it turns out that if you would do the composition of both of these functions both ways, f of g of x and g of f of x, then you would actually get the answer x. So both of these functions, if you will graph them, then they are symmetric about the line y equals x. Now what if you were given a function and you were told to find the inverse function? And these are the steps to finding the inverse function. So first we would change the f of x to y if there was an f of x in the equation. So first what we'll do is change the f of x to y if there were an f of x in the equation. Then we will switch the x and y variables. We'll then solve for that new y, and we will replace the y with a notation for the inverse. And that notation is, it looks like f of -1 and x in parentheses. So here I'm looking at some problems from a pre-calculus text, and here under skills and applications it says in exercises 7 to 14, find the inverse function of f informally. We're gonna find the inverse function for number 9. F of x equals x plus 9. So we have f of x equals x plus 9, and you're gonna have to memorize the steps to finding the inverse. The first step is to change this f of x to a y, and we know that f of x is equivalent to y, so that could help you memorize the first step. So y equals x plus 9. That's the first step. What's the second step? Second step is to switch the x and y. So instead of writing y here, we're going to write x, and instead of writing x, we're going to write y. Do you know the third step? Solve for y. So in order to solve for y here, we have y plus 9. We want to get rid of the plus 9 on this side, so we're going to have to subtract. We're going to have to subtract 9 from both sides. Now when we do that, 9 minus 9 goes away. That's what we wanted. And we have y on this side, and we have an x minus 9 on this side. What's the last step? We're going to change y to the inverse notation, which it looks like f of -1, but it's really not f of -1. It's just the notation for the inverse function. So I'm going to rewrite it where that symbol or that notation comes first. and we have x minus 9. So x minus 9 is the inverse of x plus 9. Okay, let's try f of x equals 3x plus 1. Let's go through the steps again. First, change the f of x to y if it's not y already. Then we will switch the x and y. So I'm going to color code that so you can see that we switch the x and y. Okay. Now what we'll do is solve for y. First, what we need to do? We need to get rid of this 1. Then that will cancel. So now what we have is x minus 1 equals 3y. Then we need to get rid of this 3. And we have to divide everything over here by 3. Then the 3's cancel. So we have y equals x minus 1 over 3. Last step, we'll just change that y to the symbol f for raised negative 1 of x equals x minus 1 over 3. So therefore, x minus 1 over 3 is the inverse of 3x plus 1. Let's do a more challenging problem. Now let's say we had f of x equals x plus 3 divided by x minus 2. So at first we just change this f of x to y. Then we're going to switch out. So I'm going to put this in red, that my y changed to an x. My x is going to change to a y. Okay, so we got to solve for y now. Now y is in the numerator and the denominator. I really need to get these y's grouped together. So what we're going to do is first get rid of this division going on here. And what we can do is multiply both sides by the denominator. That's how we get rid of fractions. We multiply the denominator we multiply both sides by the denominator. So the denominator here is y minus 2. Let's multiply both sides by y minus 2. In doing so, the y minus 2's cancel here. That's what we want. Now this is y minus 2 times x on the left side. So let's distribute, because we really need to get this y isolated. So let's distribute. Y times x is xy times this negative 2 times x is negative 2x equals y plus 3. Now what you need to do now is locate your y's, because really we need to get the y's together. We have a y here and we have a term that has a y in it. So we actually need to get these two terms together on one side. Okay, so what do we have here? We have xy minus 2x equals y plus 3. And if we're trying to get the y terms together, what we can do is subtract y from both sides. And if we subtract y from this side, it'll pop up on this side. And if we add the 2x, it'll go on this side. So let's subtract y from both sides. And I'm going to put it right here. So that we subtract y, then that will cancel. And we have 3 right now. Xy minus y minus 2x. So what I did was just place that y right behind it, because I know now that I add the 2x, then it's just going to pop up on this side. It's going to cancel. We have xy minus y equals, you can write it in order, it doesn't matter, 2x plus 3. Okay, great. We have our y terms on the same side. So what we can do now is factor it out in y. Factor out the y. Alright, so y times x minus 1. So I basically had to take the y out because I know that I factored correctly, because if I multiply this, I get back what I started. And we have 2x plus 3 on this side. How can we isolate the y here? We basically just divide both sides by x minus 1. Therefore, our answer is y equals 2x plus 3 over x minus 1. And of course, we can write our symbol for the inverse function like so.